imagine a wildfire is going to start tomorrow afternoon at like exactly 3 p.m.
Okay.
Right now, no one has lit a match, no lightning has hit the ground, the forest is completely quiet.
Right. Totally peaceful.
Yeah, but a computer sitting in a building, thousands of miles away, already knows exactly which acre of those trees will burn first.
It's crazy to think
It
about.
really is. And welcome to this deep dive, by the way. Today, we are exploring a really fascinating question for you, the listener. Can artificial intelligence, actually help protect our planet?
It's a question that completely changes how we think about the future, honestly. Because usually when we think about computer programs, we think about being stuck inside.
Yeah, totally.
We picture an office building, a laptop screen, maybe typing an email or playing a video game. We do not usually connect, computer code with the actual natural world outside our windows.
Right. The worlds of nature and computers feel completely separate, like they have nothing to do with each other.
Exactly. But when you step into the modern world of environmental science, you aren't just looking at a small screen in a small room anymore. You're looking at the entire planet.
Oh, wow.
Yeah, you're looking at deep oceans, massive forests, and sprawling cities. And the reason we're looking so closely is that our planet is facing some incredibly massive, complicated challenges right now.
I mean, we're talking about really severe problems.
Very severe. We are looking at widespread climate change. We're dealing with air pollution, where, the air we breathe is just filled with harmful particles.
Yeah.
We have water pollution, meaning the lakes and rivers we rely on for drinking and farming are becoming dirty and unsafe.
And the list of problems just keeps going. I mean, we're seeing devastating wildfires spreading across natural areas.
Right.
We're experiencing major floods where water completely covers land that is usually dry and totally safe. And at the exact same time, in other places, we're seeing terrible droughts.
Yeah, where there's simply not enough rain and the land basically just turns to dust.
We also have to manage hurricanes, right? Which are massive, dangerous storms carrying huge amounts of energy. And we're dealing with rapid deforestation.
Which is just the act of cutting down far too many trees without replacing them.
Right. And we are measuring rising temperatures all over the globe, meaning the entire world is just getting hotter year after year. And driving a lot of this are carbon emissions.
Yeah, carbon emissions are a huge piece of this.
Let's actually define that simply for a moment, just so we're all on the same page. Carbon emissions are basically the invisible gases we put into the air, mostly from burning things for energy.
Exactly.
And those gases, they trap the sun's heat and cause this overall heating of the planet. So when you look at that entire list, the storms, the dirty water, the dead trees, the invisible gases, these are massive, complicated problems.
They're moving targets. They're not easy to solve at all.
Which brings us directly to the core mission of our discussion today. The central question we're exploring is, can AI, artificial intelligence, actually help protect our Earth from these massive threats?
Okay, let's unpack this. Because when I first consider that question, I admit I feel a bit skeptical.
Skeptical how?
I think, how in the world can a computer program stop a fire from burning or stop a flood from destroying a town? Computers can't build walls or spray water.
Right. They don't have hands. And that skepticism is totally fair. It leads right to the most important initial takeaway we have.
Which is?
AI is an incredibly powerful tool, like maybe one of the most powerful tools we have ever built to understand the Earth.
Yeah.
But it absolutely cannot save the Earth alone.
Right. It's not a magic solution that fixes everything while we just sit back and watch.
Exactly. It needs human beings.
AI requires a massive team effort. It needs everyday people. It needs local and national governments.
Yeah.
It needs dedicated scientists, private companies, and entire local communities. All of these different groups must work together.
So AI is just a tool in the toolbox.
Exactly. The responsibility to actually use that tool and make hard choices still falls completely on our human shoulders.
So if we think of AI, we should think of it as a very smart, very fast assistant. It's helping us understand what is happening, but we still have to go out and do the actual hard work of fixing the problems.
Yeah, that makes sense.
Think about your own daily life. If you have a smart assistant on your phone that tells you it's going to rain, the phone doesn't hold an umbrella over your head.
Right. You still have to grab the umbrella and walk out into the storm.
That is exactly right. The assistant gives you the knowledge, but you take the action. So I want to invite you, the listener, to really explore exactly how AI acts as this smart assistant for the entire Earth.
Because before an assistant can help you solve a problem, it first has to be able to see that the problem even exists.
Right. You can't fix a broken pipe in your house if you don't know it's leaking.
Exactly. You can't fix the Earth if you can't see what's wrong with it.
And seeing the Earth is much harder than seeing a leaky pipe. That is why we use a specific approach called remote sensing. This is the very first step in how AI helps us.
Remote sensing. Let's break that concept down so it makes perfect sense for everyone.
Yeah, so the word remote means far away. Think of the remote control for your television. You can change the channel from all the way across the room without touching the TV.
Right.
And the word sensing means getting information, like seeing with your eyes or feeling with your hands. So remote sensing means collecting information about the Earth from far away without touching it directly.
That is exactly what it is. We are gathering incredible amounts of information from a distance. And to do this, we use three very specific types of tools.
Okay, what's the first tool?
The first tool is satellites in space. These are complex machines flying very high up in orbit above the Earth. They are constantly taking pictures and gathering data as they look down at the entire planet.
They give us the absolute biggest picture possible, right? Like a satellite can see a whole continent at once.
Exactly.
But satellites are very far away, and sometimes there are clouds in the way. So what's the second tool?
The second tool brings us closer to the ground. These are drones flying in the sky. Drones are small, uncrewed flying machines.
Okay.
And because they fly much lower than satellites, they fly under the clouds. They can take incredibly detailed pictures of a specific forest or a specific farm.
Oh, I see. So the satellite sees the whole forest, but the drone can fly down and see the individual leaves on a single tree.
Exactly. And then we have a third tool, which is right down in the dirt.
Yes, the third tool involves sensors placed directly on the ground. A ground sensor is just a small machine that sits in one place and constantly measures exactly what's happening around it.
What kind of things do they measure?
Well, these sensors can collect data on the exact temperature of the air in that one spot. They can measure the air quality, telling us exactly how many dirty particles are floating by.
That's super useful.
They can also measure soil moisture, which just means how wet or dry the dirt is right beneath the sensor. And they can be put in rivers to measure the exact water levels, watching to see if the water is rising or falling inch by inch.
So when you put all of this together, you have satellites looking down from deep space, drones buzzing through the sky above the trees, and sensors sitting right there in the dirt and the water.
Yeah, it's a lot of tools.
They're all gathering a constant, never-ending stream of data. They're collecting millions of pictures and numbers every single day, every single hour.
And this brings up a huge question. We have all these pictures, we have all these numbers. Why do we need artificial intelligence for this?
Right. Why not just look at it?
Exactly. Human beings have eyes. We can look at pictures. We can read the numbers on a screen. Why involve a complex computer brain?
The reason we need AI is because of the sheer size of the problem. The Earth is unimaginably huge. Human beings simply cannot check every single forest, every single river, every farm, and every city by hand.
We just don't have the people.
Right. We do not have enough people, and we do not have enough time.
Imagine trying to look at a photograph of every single tree in your own city to decide if each tree is healthy or sick. Just in one city, that project would take you years.
Oh, absolutely.
By the time you finish, the first trees you looked at might have already died.
Exactly. And this is where AI introduces its ultimate superpower, incredible speed.
Speed is the key here.
AI can analyze mountains of data in the blink of an eye. If a satellite takes a massive stack of thousands of images of a forest every single day, an AI system can look at that entire stack instantly.
Wow.
It can compare yesterday's picture to today's picture and spot the tiniest differences faster than any human ever could.
But comparing satellite photos using AI isn't just a simple game of spot the difference, is it?
No, it's much more than that.
It's more like a doctor looking at an MRI scan. The AI isn't just looking at a normal photograph of the surface of a tree. It's looking at special data gathered by these tools.
Right.
It can look at different types of light to measure the health inside the leaves, basically diagnosing a forest with an illness before the leaves even turn brown to human eyes.
That is a brilliant way to explain it. AI is diagnosing the Earth. Let's look at some specific ways this is applied, starting with forests.
Okay, let's do it.
AI monitors these giant forests by spotting early signs of deforestation. It can see where trees have been cut down illegally. It can identify tree loss from disease.
It spots the difference between a healthy green forest today and a slightly less healthy forest tomorrow.
Exactly. Water is another massive area. AI can constantly check the health of lakes, rivers, and ocean coastlines.
So it's looking for, like, Floating garbage.
It doesn't just look for floating garbage. By analyzing the data in the images, AI can detect chemical water pollution. It can see if the water is becoming toxic before fish start dying.
Oh, wow. That's incredible.
It also monitors our cities. Cities are always changing. AI studies urban growth, watching exactly how and where a city gets bigger over time.
Right.
You can monitor massive traffic patterns on the roads to see where pollution from cars is building up. It watches how land is used, like when a natural green area is suddenly covered in concrete.
And it monitors something really interesting called heat islands. Let's explain that for a second.
Yeah, heat islands are a big deal.
A heat island is a specific area in a city that becomes much hotter than the natural land around it. Think about a giant parking lot on a summer day.
Ugh, miserable.
Right. The black roads and the concrete buildings soak up the heat from the sun and hold on to it all night. The AI can look at a map of a city and instantly spot these dangerously hot zones.
Finally, we apply this to farms. AI can check the health of crops growing across thousands of acres. It looks for drought stress.
Drought stress.
Yeah, this means the AI can see if the plants are struggling and dying because they don't have enough water, even before the farmer walking in the field might notice the problem.
Oh, that's so useful.
It checks the soil conditions to ensure the ground is healthy enough to grow food.
So the AI processes this endless river of information. It flags that a deep forest area is slowly disappearing. It alerts us that a river near a factory is becoming polluted.
Right.
It highlights that a specific city neighborhood is getting dangerously hot. It warns us that farmland is drying out.
It finds all the problems quickly and accurately.
But wait, let me push back here for a second.
Okay, go ahead.
Is AI just pointing out things that are already ruined? I mean, if the tree is already cut down or the farm is already dried up and the crops are dead, is the AI actually helping us prevent any damage?
That's a really good point.
Or is it just a very fast news reporter telling us bad news after the disaster has already happened?
That is a crucial challenge to raise. Because if AI just tells us what is already broken, it is not much of a protective tool.
Right, it's just telling us we failed.
Exactly. Spotting a dying tree or a dry farm using a satellite is really just observing the surface of the problem. It is just the very first step.
So what's the next step?
To truly protect the Earth, to actually prevent the damage before it happens, we have to go much deeper. We need to understand the massive, invisible forces that are causing these problems in the first place.
Right. We have to shift from just watching the surface of the Earth to analyzing the complex engine that runs the Earth, the climate.
Exactly.
We need to untangle the giant, messy web of climate change.
And that takes us to one of the most difficult challenges in all of science. Climate change is a severe global crisis.
We hear the term climate change all the time, but let's list the real severe consequences we are actually facing.
Yeah, it's good to be specific.
We are talking about steadily higher overall temperatures. We are talking about much stronger, more violent storms.
That's right.
We are looking at rising sea levels, meaning the ocean water is physically expanding and creeping higher up onto our coastlines, and we are seeing extreme weather that behaves in highly unusual, surprising, and deeply dangerous ways.
The biggest difficulty with climate change is simply understanding how it all works together. It is incredibly hard to study.
Why is it so hard?
The reason it is so hard is that the climate is not just one thing. It is a massive collection of complex systems. And every single one of these systems interacts with all the others.
What exactly are these interacting systems? Like, what are we talking about here?
Think about the atmosphere, the huge blanket of air surrounding the whole planet. Then you have the deep oceans covering most of the Earth.
Okay.
You have the solid land. You have the giant forests. You have the massive sheets of ice at the North and South poles. You have human cities. And you have all of our human activities like driving cars and running factories.
That's a lot of moving parts.
It is. Every single one of these elements constantly pushes and pulls on all the other elements.
It really is a giant, messy, tangled web. If humans build a massive new city, we put different gases into the air. That changed air holds more heat.
Right.
That extra heat warms up the ocean. The warmer ocean water melts the ice. The melting ice changes how the ocean water flows. It's just an endless chain reaction.
And what's truly fascinating here is how perfectly suited artificial intelligence is to untangle this web.
Really?
Yeah. A human brain, even the smartest scientist in the world, has a very hard time looking at the air, the ocean, the ice, and the cities, all at the exact same moment.
Our brains just can't process all those connections at once.
But AI excels at exactly this kind of work. AI is built to find hidden patterns in giant, messy webs of data.
A pattern simply means how things happen in a repeating, connected way. If event A happens, then event B usually follows.
Exactly.
AI can learn the complicated rules of this global game, even when the game has millions of moving pieces.
Yes. The AI can analyze decades of temperature data. It can study complicated historical patterns of rainfall across the world.
Wow.
It can build highly detailed computer models to show exactly how and why droughts happen in specific places. It can accurately estimate where invisible carbon emissions are coming from. And it can use all this pattern recognition to help predict extreme weather.
By finding these deep patterns, AI helps scientists answer some very specific, massive questions.
Questions we desperately need answers.
Exactly. Let's walk through them. First, the AI can help answer which specific areas of the world will become dangerously hotter in the future.
Second, it helps answer which places will face more severe droughts, losing their rain for long periods of time.
Third, which cities and coastlines will face more flooding as the sea levels rise and storms get heavier.
Fourth, which human industries and factories are actually producing the most carbon emissions, driving the problem.
And fifth, which remaining forests are the absolute most important for storing carbon.
That's a huge one.
Yeah, trees naturally pull carbon out of the air and trap it, so we need to know which forests are doing the heaviest lifting so we can protect them.
Finding the answers to these 5 questions is incredibly important. Without these answers, any climate action is just a blind guess.
But let me bring this back to the listener sitting at home right now. Why should you care if a giant supercomputer can answer these big, abstract questions about climate patterns?
It's a fair question.
How does this actually change anything on the ground? Well, the real power here connects directly back to human action. When we have a clear understanding of the problem, we can make vastly better decisions about how to survive it.
Exactly. The AI provides the blueprint, and then different groups of people can take real physical action. Governments, for example, can use the AI's answers to write much better policies and laws. If they know exactly which industry is polluting the most, they can regulate it.
Okay, that makes sense.
Cities can use the data to build smarter infrastructure. If the AI clearly shows that a specific coastal city will face serious flooding in the next 20 years, that city can start building stronger seawalls right now to hold back the water.
Farmers can use this too. If the AI models predict that a specific farming region is going to face a severe multi-year drought starting next season, those farmers can begin saving water immediately.
Yes, exactly.
They can plant different types of crops that need less water. Scientists use these AI answers to design even better, more accurate models for the future. And entire local communities can physically prepare their homes and emergency plans for extreme weather.
AI does not remove the reality of climate change. The planet is still heating up. But what AI does is give us clarity.
It's like walking through a very dark, unfamiliar room full of dangerous furniture.
I love that analogy.
The AI does not magically turn on the lights, but it hands you a highly detailed map of exactly where every table and chair is located. It removes the blindfold so you can walk safely.
That is a perfect way to visualize it. Long-term climate modeling gives us the map. It helps us plan for what the world will look like next year, or 10 years from now, or 50 years from now.
But modeling what the climate looks like in 10 years doesn't help a family facing a massive flash flood tomorrow morning.
No, it doesn't.
Long-term planning is great, but what happens when an extreme weather event is right on our doorstep? That requires a total shift. We have to move from long-term pattern recognition to real-time, split-second survival warnings.
And this transition brings us to one of the most critical uses of this technology,
Yeah.
AI and immediate disaster prediction.
Natural disasters are a direct, terrifying threat. They happen fast, they can heavily damage homes,
Right.
they can wash away vital roads, they can ruin entire farms and decimate forests, but most importantly, they're a direct threat to human lives.
Because disasters strike so fast, AI is used to build advanced early warning systems. An early warning system does exactly what it sounds like. It tells us a deadly danger is coming long before it actually arrives, giving us the chance to react.
Let's talk about wildfires first as a prime example. A wildfire can start from a single spark, very small, but it can spread out of control across miles of forest incredibly quickly.
Yeah, terrifyingly fast.
How does an AI system actually help predict and warn us about something so chaotic?
It works by combining many different streams of data into one single picture. The AI takes a specific recipe of information.
Okay, what's in the recipe?
It takes the big satellite images from space. It takes the close-up drone images from the sky. It pulls in live weather data, like the temperature and wind speed.
Right.
And it pulls in the data from those small sensors sitting on the ground.
Uh,
By constantly crunching all these pieces together simultaneously, the AI can detect a severe fire risk much earlier than any human watching a camera.
let's break down how that recipe works in reality. Maybe the satellite high up in space sees a tiny, almost invisible change in heat in a deep part of the forest.
Okay, yeah.
The drone footage from last week shows that the trees in that exact area are completely dried out from a disease. The live weather data shows that extremely strong winds are blowing directly toward that dry spot.
Right.
And the ground sensor sitting in the dirt confirms the soil has zero moisture. A human forecaster might only be looking at the wind speed,
Exactly.
that the AI looks at every single detail at once and calculates, a massive fire is highly likely to start right here, right now.
Exactly. It connects dots that human brains simply cannot connect fast enough.
Right.
We see a similar recipe used for predicting dangerous floods.
Floods typically happen after a period of heavy rainfall, right? Or during massive storms or when large rivers suddenly rise over their banks.
Yes.
So how does the AI predict a flood before the water even reaches the town?
Again, it analyzes multiple complex factors at the exact same time.
Yeah.
The recipe for a flood prediction includes rainfall data, exactly how much water is falling from the sky per hour.
Okay.
It includes current river levels, how much water is already sitting in the river channels. It heavily relies on land elevation data. Elevation just means how high or low the physical ground is, because gravity forces water to flow down into the lowest areas.
And it also looks deeply at soil moisture. Right, this is a huge factor.
It is massive.
If it's been raining all week, the soil is already totally wet, like a sponge that is completely full. It can't drink any more rain.
Right, the sponge is full.
So if another storm hits, that new water has nowhere to go but to flow over the surface and cause a flood.
Exactly.
And finally, the AI factors in the future weather forecasts. The AI analyzes all these massive variables together instantly. And because it does this, it can predict the exact streets and neighborhoods that are at the highest risk of flooding tomorrow.
The same principles apply to tracking hurricanes. These are massive, swirling storms bringing extreme wind, heavy, blinding rain, and severe ocean flooding.
Yeah, they're monsters.
AI can rapidly analyze the complex movement and pressure systems of the storm to predict exactly where it will hit the coast. This early storm tracking supports much better, faster public warning systems.
So using AI for disaster prediction is essentially like installing an incredibly advanced futuristic smoke detector in your house.
I like that.
A normal smoke detector only makes a loud noise when the fire is already burning and filling the room with smoke. By then, you are already in danger.
Exactly.
But this AI smoke detector can tell you that a fire is going to start in your kitchen tomorrow because it noticed the wiring is old, the room is dry, and the oven is running too hot. It warns you before the smoke even exists.
That early warning is the entire point. If people receive accurate warnings much earlier, they have more time to prepare. In a natural disaster, time is the single most valuable resource you can possibly have.
Yes, if you have time, you have options. People can safely leave dangerous areas without panicking.
Right.
They can protect their homes by putting up sandbags around their doors to block the water. Emergency rescue teams, like firefighters, police, and medical workers, can position themselves closer to the danger zone before the disaster even strikes, allowing them to respond instantly.
Exactly.
Ultimately, these AI early warnings reduce physical damage and save human lives.
But I think we need to pause here and look at this critically. Think about your own neighborhood.
Okay.
If an AI system suddenly sends an alert predicting your exact street will flood tomorrow, do we just automatically sound the alarms and evacuate an entire city based purely on a computer's guess? Do we blindly follow the machine?
That is a fascinating question. Would you pack up your entire life and leave your home just because a server in another state told you to?
Right.
This leads to a very important reality check.
The information we have provides a vital, serious warning about using this technology. AI predictions are never completely perfect.
Right.
A prediction is exactly that, a prediction. It is an educated guess based on mathematical data. It is not a magical crystal ball.
Because the weather and natural disasters are incredibly chaotic.
Exactly. The AI might simply be wrong. The wind might suddenly change direction at the last minute. The heavy rain might stall over the ocean and never reach the town. The storm might break apart.
So it's not a guarantee.
Because of this unpredictability, there is a strict rule when using these tools. Human experts must always check the computer's results. Human professionals must make the final, difficult decisions.
That makes sense.
Evacuating a city is a life or death decision with massive consequences, and we cannot just hand over the keys to a machine and trust it blindly.
Okay, let's step back and look at the big picture. We have explored how AI acts as an eye in the sky to monitor the Earth.
Yes.
We have seen how it untangles the deeply complex web of climate change to answer big questions. And we've discussed how it acts as an advanced early warning system for deadly disasters. Let's summarize exactly what humanity gains when we put all these different pieces together into action. There are 4 massive benefits to using AI for the environment. Let's refer to them as the 4 big wins.
Okay, the first big win is much faster monitoring. We have touched on this throughout our discussion, but it is the foundation of everything else.
It's all about speed.
AI has the unique ability to process massive, overwhelming amounts of environmental data incredibly quickly. It can scan millions of satellite images, drone videos, and ground sensor readouts much faster than any human team ever could. Unmatched speed is its primary strength.
The second big win is vastly better decision-making. When governments, leading scientists, and local communities have access to this fast, clear, and highly detailed information, they can act with confidence. They don't have to guess anymore.
For instance, if an AI model clearly shows that a specific neighborhood has a very high flood risk due to low elevation and poor soil drainage, the city government can actively improve the local drainage systems before it rains.
Like fixing the pipes.
Yes, they can install larger pipes to quickly move the water away from the houses. Or they can design highly specific emergency evacuation routes so everyone knows exactly which roads will be safe.
Another practical example. If the AI monitoring system spots that a remote, protected forest area is suddenly losing trees at a rapid pace, the local government can immediately step in.
Right.
They can send forest rangers to stop the illegal loggers who are cutting down the trees.
And if the AI detects that a specific city zone is experiencing a dangerous spike in air pollution, local leaders can take immediate action to protect public health.
What kind of action?
They could issue a temporary rule limiting the number of cars allowed on the road in that area for the day. Better, faster information leads directly to smarter, more effective decisions.
The third big win is stronger overall environmental protection through early detection. We mentioned this earlier, but finding a serious problem in its early stages buys us our most precious resource time.
When we identify environmental threats early, we have the time required to actually solve them. AI helps us buy time to protect massive forests before they burn.
Yeah.
It buys time to protect clean water sources before they are completely poisoned. It buys time to protect wildlife, the animals living in these natural habitats before their homes are destroyed.
Right.
It helps protect entire cities from extreme heat. And above all, early detection helps protect vulnerable people from fast-moving natural disasters.
Now let's move to the fourth big win. This one is entirely about actively supporting climate action. And here is where it gets really interesting.
Oh, definitely.
Because up until this point in our discussion, we have mostly talked about AI tracking the bad things. It acts as a guard dog watching for forest fires, sudden floods, and dirty pollution.
Right.
But AI does not just watch for danger. It can actively help manage the good things we are building. It strongly supports green technology and clean energy.
That is a vital point. AI can comprehensively track where carbon emissions are coming from, but it also helps us study renewable energy systems and massively improve how we use that energy.
Let's focus deeply on that. Renewable energy, also called clean energy or green energy. We are talking about solar power collected from the sun's rays and wind power collected from giant wind turbines.
These are great, clean sources of energy.
But how does artificial intelligence actually help us use wind and sunlight?
AI is used to actively manage the complex electrical systems that power our world. Specifically, it helps balance the power grid.
Balancing the power grid. What does balancing actually mean in this context? Let's break that mechanism down so it makes sense.
Imagine a large, modern city that is trying to run entirely on solar power and wind power. There is a fundamental challenge with this. Nature is not perfectly steady.
Right.
The sun is not always shining. Sometimes it is cloudy, and of course it goes down every night. The wind is not always blowing. Some days are completely still. But the humans living in that city constantly need electricity. They need to run their refrigerators, keep the hospitals operating, and light their homes. This constant need is called energy demand.
So you have a supply of energy that goes up and down based on the weather, and you have a demand for energy that goes up and down based on what humans are doing. If those two things don't match perfectly, the city's power fails.
Exactly. And this is where AI steps in as the ultimate manager. The AI can analyze the live weather forecasts to predict exactly how much solar and wind power will be generated in the next hour.
Oh, wow.
At the exact same time, it analyzes the patterns of human behavior to predict exactly how much electricity the city will demand in that same hour.
It looks at the incoming weather and the incoming human needs, and it balances the two sides of the scale.
Yes, it perfectly balances the entire system moment by moment. If the AI knows the wind will stop blowing tomorrow afternoon, it can ensure that extra solar power is stored in giant batteries today to cover the gap.
That's incredibly smart.
By doing this, the AI ensures the city always has steady power, and it makes sure not a single drop of clean energy is wasted. This makes the entire green energy system vastly more efficient and reliable.
So AI is useful not just for sounding the alarm about climate problems, but it is actually an essential tool for managing our best climate solutions. It makes green energy work.
It really does.
When you lay out these four big wins, it all sounds like a perfect, flawless partnership. AI tells us what to do, it balances our power, it warns us of danger, and we just follow the instructions. But let's be real.
Yeah.
Every powerful tool has a dangerous edge if it is used incorrectly or misunderstood.
That is an incredibly important shift in our perspective. We cannot just blindly praise AI. We have to look closely at the roadblocks. We need to examine the paradoxes and the deep pitfalls of this technology. There are four major challenges when using AI for the environment that we must understand.
Let's go through these challenges one by one. Challenge number one is data quality.
There is a very old golden rule in the world of computer science. Bad data leads to bad decisions. An AI system is only as smart as the information you feed into it.
Right.
AI requires highly accurate, high-quality data to work properly. If the data fed into the AI is incorrect, incomplete, or heavily biased, the AI will confidently give you the wrong answers.
Let's think about how serious that can be. If a flood prediction model is trained using poor quality data, maybe the ground sensors were broken and sending the wrong soil moisture numbers, the AI might completely fail to warn a town that is in real imminent danger.
Exactly.
A massive flood arrives and no one was prepared because the computer said everything was fine. Or, flip that scenario around, the AI might issue terrifying warnings to the completely wrong location.
Which is also terrible.
Right. It might cause a massive panic and force a town to evacuate when there is absolutely zero danger. Bad data has real-world consequences.
That leads directly to challenge number two, which is accuracy and understanding. As we explored in depth earlier, environmental systems are unimaginably complex. Weather, deep ocean currents, land elevation, water flow, human activity, they all interact in a chaotic web.
And the concern here is that while AI is incredibly good at finding mathematical patterns in the numbers, it may not actually understand the whole complete reality of the natural system.
Right.
The AI is essentially a black box. It sees the numbers going up and down, and it recognizes the pattern, but it doesn't truly understand the physical why behind those numbers. It doesn't know what a tree or river actually is.
Because of this lack of true understanding, scientists and environmental experts must rigorously and constantly test these AI models. We have to check their math against reality. We absolutely cannot just trust the machine's output without verifying it first through human scientific testing.
Now we arrive at challenge number 3, and I have to admit, this is perhaps the most shocking and contradictory challenge we face. I call it the energy paradox.
It is a massive paradox. We have talked entirely about how AI is a tool to fight climate change. But AI systems themselves require a truly massive amount of electricity to operate.
Yeah.
This is especially true for the very large, complex AI models and the gigantic data centers, the massive warehouses full of constantly running computer servers where these AI brains physically live.
These servers run incredibly hot and require huge amounts of power just to stay cool and process data. So let's look at the contradiction. We are heavily using AI to solve climate change, to balance green grids, and to stop carbon emissions.
Right.
But if the massive amount of electricity powering those giant AI data centers is generated by burning fossil fuels like coal or natural gas, then the very act of using the AI is actually creating huge amounts of new carbon emissions.
It is a direct contradiction. We are fighting pollution by creating more pollution.
It's wild.
This is a profound problem, and it demands a very clear mandate for the tech industry. If we are going to use AI to protect the environment, we must urgently make AI technology itself more environmentally friendly.
We have to.
We must run these data centers on the clean energy they are helping to manage. The tool we build to save the Earth cannot simultaneously be the tool that destroys it.
And that profound paradox brings us to challenge number 4. This is the final challenge, and it is the most human challenge of all. It's about human responsibility.
If we step all the way back and connect everything we've discussed to the absolute biggest picture, we have to realize that AI is fundamentally just a messenger. It's an incredibly fast, smart messenger, but it is only delivering information.
Right.
The machine cannot move physical objects in the real world. Human beings must take the actual action.
Let's look at 3 very clear examples to prove this point. Example 1, the AI system works perfectly. It alerts us that a protected ancient forest is rapidly disappearing. It shows us the exact high-resolution satellite pictures of the damage.
Okay.
But the AI code cannot arrest anyone. It cannot plant a new tree. Human beings must physically travel to that forest, confront the illegal loggers, and stop them.
Example 2. The AI perfectly analyzes the traffic patterns and tells us a major city has terrible, dangerous air pollution choking a specific neighborhood.
Right.
But the AI cannot write new laws. It cannot shut down a factory. Local human leaders must find the courage to write better policies and enforce those laws to stop the pollution.
And example 3. The AI successfully processes 1 million data points and correctly predicts that a deadly flood is coming tomorrow. It draws a bright red warning circle on a digital map.
Yeah.
But that AI cannot drag sandbags to block the water. It cannot pull a trapped family out of a flooded house. Human emergency teams must do the hard, dangerous work of rescuing people.
AI is a powerful tool, but human action, human bravery, and human effort are the actual keys to survival.
Which brings us back, finally, to the ultimate answer to the core question we asked at the very beginning. We have taken a long, deep journey today. We started by looking honestly at the massive, terrifying problems the Earth faces right now. The heat, the storms, the pollution.
Yeah.
We looked closely at how AI acts as an eye in the sky, using remote sensing from satellites and drones to play an advanced game of spot the difference across the globe.
We saw how AI is uniquely designed to untangle the messy, chaotic web of climate change, helping scientists answer the biggest questions about heat, drought, and carbon. We discussed exactly how it combines rain, river, and soil data to act as a vital early warning system for fast-moving disasters.
We looked at the 4 big wins, how it gives us faster monitoring, how it leads to smarter decisions, how early protection buys us the gift of time, and how it actively manages efficient green energy grids.
Right.
But we also stared directly at the hard challenges, the danger of bad data, the machine's lack of true understanding, the massive energy paradox of carbon-emitting data centers, and the absolute unavoidable need for human action.
So returning to that central question, can artificial intelligence actually help protect the Earth?
The verdict is clear.
Yeah.
Yes, AI can absolutely help. It is one of the most amazing, capable tools humanity has ever invented. It monitors the globe tirelessly, it analyzes complex chaos, it predicts hidden dangers, and it manages our clean energy solutions.
But the reality of the ultimate partnership is just as clear. AI absolutely cannot do it alone. It needs clean, renewable energy to power its own massive data centers so it doesn't cause more of the pollution it is trying to stop. It requires perfect, unbiased data to learn from.
It requires dedicated human experts to test its math carefully and make sure it isn't hallucinating. And most importantly, it requires human beings to look at the perfect map the AI provides and actually take physical action in the real world. The future of environmental protection is not about machines saving us.
No, it's not.
It is about a deep partnership between advanced technology and human responsibility.
The Earth is our only home. Protecting it is not just an interesting scientific task for advanced computer programs. It is a fundamental human responsibility that we cannot outsource to a machine.
Before we go, we want to leave you, the listener, with one final provocative thought to ponder. We want to build on this idea of human responsibility. Think about this scenario.
Okay.
Imagine the AI works perfectly. It has flawless data. It perfectly understands the complex climate web. And it hands a city government the perfect, mathematically flawless plan to stop a terrible impending flood and save the environment.
The machine has done its job perfectly. But what if that perfectly mathematically correct plan requires permanently tearing down a beloved historic human neighborhood?
Oh, wow.
What if following the plan is incredibly disruptive and enormously expensive for the local families living there? What if the perfect scientific answer generated by the computer is a deeply unpopular, painful human answer?
Who makes that final agonizing choice? The AI can hand us the perfect logical map to protect the Earth, but we still have to decide as humans if we're actually brave enough to follow that map, even when the path it shows us is incredibly difficult and requires deep sacrifice. The machine can do all the perfect math, but at the end of the day, humans have to live with the consequences of the answers.
That tension between perfect computer logic and messy human reality is something we must all think deeply about as this technology grows more powerful every day.
Thank you so much for joining us on this deep dive into AI and the environment. We hope this exploration has helped you understand both the immense power of this new tool and the unchanging importance of our own human actions. Keep learning, keep questioning the world around you, and always remember that protecting our planet requires both incredibly smart machines and deeply responsible humans. Goodbye for now.
Goodbye, and thank you for taking this journey with us.